Well drilling is the process of drilling a hole in the ground for the extraction of a natural resource such as groundwater, brine, natural gas, or petroleum, for the injection of a fluid from surface to a subsurface reservoir or for subsurface formations evaluation or monitoring. Drilling for the exploration of the nature of the material underground is best described as borehole drilling. The earliest wells were water wells, shallow pits dug by hand in regions where the water table approached the surface, usually with masonry or wooden walls lining the interior to prevent collapse. Modern drilling techniques utilize long drill shafts, producing holes much narrower and deeper than could be produced by digging. Well drilling can be done either manually or mechanically, and the nature of required equipment varies from extremely simple and cheap to very sophisticated. Managed pressure drilling is defined by the International Association of Drilling Contractors as an adaptive drilling process used to more precisely control the annular pressure profile throughout the wellbore. The objectives of MPD are to ascertain the downhole pressure environment limits and to manage the annular hydraulic pressure profile accordingly. Drill bits in mechanical drilling. Several factors affect drill bit selection. Due to the high number of wells that have been drilled, information from an adjacent well is most often used to make the appropriate selection. Two different types of drill bits exist, fixed cutter and roller cone. A fixed cutter bit is one where there are no moving parts, but drilling occurs due to shearing, scraping or abrasion of the rock. Fixed cutter bits can be either polycrystalline diamond compact or grit hot pressed inserts or natural diamond. Roller cone bits can be either tungsten carbide inserts for harder formations or milled tooth for softer rock. The manufacturing process and composites used in each type of drill bit make them ideal for specific drilling situations. Additional enhancements can be made to any bit to increase the effectiveness for almost any drilling situation. A major factor in drill bit selection is the type of formation to be drilled. The effectiveness of a drill bit varies by formation type. There are three types of formations: soft, medium and hard. A soft formation includes unconsolidated sands, clays, soft limestones, red beds and shale. Medium formations include calcites, dolomites, limestones, and hard shale. Hard formations include hard shale, calcites, mudstones, shitty limestones and hard and abrasive formations. The first roller cone patent was for the rotary rock bit and was issued to Howard Hughes SR in 1909. It consisted of two interlocking cones. Walter Benona Sharp worked very closely with Hughes in developing the rock bit. The success of this bit led to the founding of the Sharp Hughes Tool Company. In 1933 two Hughes engineers, one of whom was Ralph Newhouse, invented the tricone bit, which has three cones. The Hughes patent for the tricone bit lasted until 1951, after which other companies made similar bits. However, Hughes still held 40% of the world's drill bit markets in 2000. The superior wear performance of PDC bits gradually eroded the dominance of roller cone bits, and early in this century PDC drill bit revenues overtook those of roller cone bits. The technology of both bit types has advanced significantly to provide improved durability and rate of penetration of the rock. This has been driven by the economics of the industry, and by the change from the empirical approach of Hughes in the 1930s, to modern-day domain finite element codes for both the hydraulic and cutter placement software. Until 2006, market share was divided primarily among Hughes Christensen, Security DBS, Smith Bits, and Readercalog. By 2014, Altura and Varel International had together gained nearly 30% of the U.S. bit market and eroded the historical dominance of the Smith, Halliburton, and Baker Hughes. Evaluation of the dull bit grading is done by a uniform system promoted by the International Association of Drilling Contractors. See Society of Petroleum Engineers/IADC Papers SPE 23938 and 23940. See also PDC bits. See also, blowout, drag bit, drilling mud, drilling rig, driller, deep well drilling, underbalanced drilling, water well, manual well drilling methods, Baptist well drilling, sludging. Bibliography: Australian Drilling Industry Training Committee Limited. Drilling, The Manual of Methods, Applications and Management. ISBN 1-56670-242-9. External links, Drilling Equipment, Drilling a Well by Automobile, Popular Science Monthly, February 1919, page 115-116, scanned by Google Books, http://books.google.com/. Books ID = 7 IG Dambaj &PG = PT33, Schlumberger Oil Field Glossary, Oil and Gas Well Drilling, U.S. Department of Labor, 1, Water Well Drilling Island, 2, Mechanical Mole Bores Crooked Wells. Popular Science, June 1942, pages 94-95, Engineering a New Approach to Fixed Cutter Bits.